Okay, now we're going to put everything we've learned in this section together to graph this function. H of x equals x cubed minus 2x over x squared minus x. Okay, so the first thing we're going to do is we're going to factor the top and the bottom. So we can pull out an x here, and this will factor as x squared minus 2 over x times x minus 1. So right away we can say what the domain is. The domain, we need to leave out 0 and 1 because those would make the denominator 0. So we'll go from negative infinity up to 0, then 0 to 1, and then from 1 to infinity. Now, what happens at places where we don't have our domain? We either have a whole or a vertical asymptote. Now, when things cancel out, like our x's here, we're going to have a whole. So we're going to have a whole at 0, comma, whatever we get in our reduced function. So here's our reduced function, x squared minus 2 over x minus 1. So if we plug 0 in there, we would get negative 2 over negative 1, which would be, the negatives would cancel out, we would have 2. So we have a whole at 0, 2. Now that'll also serve as our y-intercept because we can't have 2. So we technically don't have a y-intercept, we just have a whole instead. Okay, now that means we have a vertical asymptote at x equals 1. So at x equals 1, we can draw a dotted line. Now, we want to think about a horizontal asymptote. Since the degree of the top is higher than the degree of the bottom, if we use our 3 rules, we remember that means we have no horizontal asymptote. But since the degree of the top is exactly 1 higher, we would have an oblique asymptote. So we would take x squared minus 2, which since that doesn't have an x term, we'll put plus 0x minus 2 minus 1. So x squared divided by x is x. Remember, draw the line, change the signs. So we get x minus 2, and then x divided by x is just plus 1. So remember, to find the oblique asymptote, we only want the quotient. We don't need the remainder. So our oblique asymptote is going to be y equals x plus 1. So that's going to be a line where the y-intercept is 1 and the slope is 1. So go up 1 over 1. So we get that. Okay. Now the other thing we can find to help us graph is do our x-intercepts. And we get our x-intercepts by setting the numerator of our reduced fraction equal to 0. So x squared minus 2 equals 0. If we solve that, we'd have x squared equals 2. We take the square root of both sides, we get x equals plus or minus the square root of 2. And if you have trouble picturing the square root of 2, which is totally understandable, the square root of 2 is about 1.4. So that would be positive 1.4 and negative 1.4. So those are 2 more points on our graph. Now, what's actually happening in our graph here is that, so we can't cross through the vertical asymptote, and it's going to go out on both sides toward this line. So it's going to approach this. Those 2 points we just graphed are the only places it can cross the y-axis. And so we know it's going to approach that as it's going up. It's going to go down. And if you want to check, you can put the original into your y equals. It won't show your whole very well, but it will make sure that you have the overall shape of your graph. Okay, and make sure you put your numerator and your denominator in parentheses. Okay, now it does make our vertical asymptote kind of funny, like this little heartbeat, from a medical monitor or something. It's just kind of a quirk of the calculator. That should be a dotted line. And unfortunately, the calculators are very bad at showing holes, and especially in this case because the y-axis would kind of be through the hole. But you do see that we get the overall shape of our graph.